So this is the question. Sketch the curves y is equal to x squared plus 3 and y is equal to 7 minus x and determine the area enclosed by them. Now, to sketch those curves, I'm going to first of all start by getting their points of intersection. Points of intersection of the two curves. Points of intersection of the two curves. Points of intersection of the... So, points of intersection of the two curves. One is a straight line, actually. So what are their points of intersection? To get the point of intersection, equate them. So I'm going to equate y is equal, the curve y is equal to x squared plus 3 and the line y is equal to 7 minus 3x so that I'm able to get their points of intersection. So I'll have x squared plus 3 is equal to 7 minus 3x, then solve for value of x to get point of intersection. So x squared is equal, so plus 3x, I've brought the 3 to this side, plus 3 minus 7 is equal to 0. We solve them to get their points of intersection. So x squared plus 3x minus 4 is equal to 0. Solving for x, we will have minus 3 plus or minus square root of 3 squared minus 4 times a times c. All this divided by 2 times a using the quadratic formula. So x is equal to minus 3 plus or minus, this is 9 squared minus plus 16, that is 25. Root of 25 is 5. So all this divided by 2. So x is equal to minus 3 minus 5 will give us minus 8 divided by 2 minus 4. Or x is equal to minus 3 plus 5, that will give us 2 divided by 2, that will give us 1. So the points of intersection are at point x is equal to minus 4 and x is equal to 1. So if we come to have a rough sketch, this is what I'm going to have. So let me draw the x-axis, and at point minus 4 and at point x is equal to 1, that the curve and the line are intersecting. So I want to get a few points of the line so that I see how exactly the line goes. The line is y is equal to 7 minus 3x. Y is equal to 7 minus 3x. Let me do a rough sketch for it. Let me get the x values and the corresponding y values for this particular line. So let's say at x is equal to 0, what will be the value of y? Y will be 7. So at x is 0, y will be 7. Somewhere huko juu. So let me have this as my 1, 2, 3, 4. Remember, it's just a rough sketch. So at x is 0, y is somewhere at 7 there. Now, at x is equal to, let's get a point in between here. Let's say minus 2. And we can also have a point there because we know at this point they are meeting. So at x is equal to 1. Let me take the 1. At x is 1, we will have it at 4. At x is 1, y will be equal to 4. So our 1, this can be a half, 0.5. Our point will be there. So we have it here, and then at x is equal to, I don't need the point for 2. At x is equal to, let's say, minus 1. At x is minus 1. Roughly, if I put here minus 1, that will give me 7 plus 3, and that will be 10. So at x is minus 1. Minus 1 is somewhere here. Then it means the line will go on like this, something like this. If I was to have a rough sketch, it will be something like this. They are meeting at minus 4. Let me also have a value for minus 4. At x is minus 4. If you put minus 4 here, we will have minus 4 multiplied with this. That will be minus 12. Minus 12 minus minus, that will be plus. So 7 plus 12, that will be 19. Okay, now let's also have a rough sketch for the curve. The curve is y is equal to x squared plus 3. Now for the curve, remember we've said those two are meeting at this point. So we've seen, let me have X values and Y values for the curve. So at X, let's say at X is equal to 0. What are we going to have? The curve, we're going to have it at 3. At X is 0, the curve is going to be somewhere at 3. So you see it's below here. Let's look at the points whereby they are meeting. Obviously, we're going to have the same values. Now let's look at maybe -1. -1. At X is equal to -1, where is the curve going to be at? If you replace -1 here, you'll have Y is 4. So at -1, your Y will be at 4, maybe somewhere down here. Now we have -3, we have -4. Remember, at -4, we were having all of them meeting. Let's do the -4 for this one. At X is -4, what are we going to have? -4 squared will give us 16. 16 plus 3, 19. So at -4, they are all meeting at 19. -4, let's assume 19 is somewhere up here. So I will have this curve coming this way, this way. It's passing through this point. And then they meet again at X is equal to 1. And at X is equal to 1, they are meeting at what point? At 4. So they are meeting again here. Remember, it's just a rough sketch. So this is my curve. My curve Y is equal to X squared plus 3. And the other one was a straight line. Y is equal to 7 minus X is a straight line. So I have its few points. So I can just draw it. So it's a straight line. So it goes like that. Those are the points. So this is the curve and this is the line. Y is equal to 7 minus 3X. So when I'm being asked to get the area that is bounded by this area that is bounded or enclosed by this line and this curve, this is the area that we are looking for. This is the area that we are looking for. But in order for us to get that area, you can see the line on top is bounding the whole of this region from -4 to 1 is bounded by this line over here. So meaning I'll first of all get the whole of that area using this line minus this area that is below it, then it will give me the area that I need. So let's get the full area. It's from -4 to 1. So integral from -4 to 1. But what is enclosed by that? It is this curve here, which is 7 minus 3x dx. And then which area don't I need? This that is down here. And it is bounded by this curve. And what area is that? That area is also from -4 to 1. So minus area from -4 to 1 of what? Of this curve. And this curve is x squared plus 3 dx. So if we integrate this, then you should be able to get the answer. Now, let's see. Integrating 7, we have 7x minus 3x squared over 2. Integral is from, and what I told you, since the limits are actually the same, let's do it in a simpler way. We can put it all under one integral sign because we have the same limits. This is from -4 to 1, -4 to 1. So we can just simply write this from -4 to 1, 7 minus 3x minus x squared plus 3 dx. Then let's integrate. Integral of 7 is 7x minus 3x squared over 2 minus x cubed over 3 plus 3x. The range is from -4 to 1. Okay, so let's now replace the ranges since we've already integrated. Let's replace 1. Replacing 1, we have 7 minus 3 over 2 minus 1 over 3 plus 3. Minus, let's replace -4. So we have 7 into -4 minus 3 over 2 into -4 squared is 16 minus -4 cubed over 3 plus 3 into -4. Evaluating all that in your calculator, what do you get? I want to evaluate it as well so that I see if the answer. There's a correction here. This, if you open this bracket, this is minus, this is minus. So this will also be minus. This will also be minus. So take note of that. Let me trace it back to now evaluating. This will be minus, not plus. This will be minus. And then this will also be minus. our answer, hapo 3/4 haifai kuwa 3/2. Wapi exactly here? Because two people have asked the same question. Is it here that you're referring to? Kindly let me know if it is this that you're referring to. Yes, Newton. I don't know why you guys are of the opinion that it is supposed to be 3/4. We are integrating. Na tumeintegrate. Tuna integrate hii 3x hapa. If you integrate 3x, you will get 3x squared over 2. You will get 3x squared over 2. This is what we're integrating. It is 3x. Newton, Nyalwal, all of you are saying it's supposed to be 3/4, but it's 3/2 because what we have here is 3. So if you integrate 3x, you should get 3x squared over 2. Newton, are we together? But it's 3/2. Or there's a place where, okay, this is 3/2. So 3/2 minus, let's see. Let me go over it again. So integrating this, we get 7x. This is okay. Minus 3/2x squared minus x cubed over 3. That is okay. Minus 3x. That is okay. Replacing the values. So replacing 1, I have 7 minus 3/2 minus a third minus 3. And then minus, replacing minus 4, I have 7 into minus 4 minus, oh, I see. So this is the 3/2 that you guys are talking about. It's here. Thanks for that. So 3/2, and then replacing minus 4, we have 16 minus 4 cubed over 3 minus 3 into minus 4. Yeah, now that is okay. Yeah, Newton, I've seen. Yes, it is 3/2 down here. Okay, if we evaluate this, guys, what are we getting finally? Let's confirm. Ndungu, you're getting 18.167. Anyone else? If you evaluate that correctly, the area is 20.833 square units. 20.833 square units, correct. Thank you, Bill. Okay. I hope that is clear. I hope that is clear. Let's tackle another question, one last question on area. Let's tackle one last question on area. So this is going to be our question number 4, I guess. This is going to be our question number 4. So determine the area bounded by, determine the area bounded by determine the area bounded by the curve y is equal to x cubed, the x-axis, and the lines, x is equal to 2 and x is equal to 3. Determine the area. Ndungu, you see the reason as to why you're sketching. Yes, you can work it out, but the reason as to why you're sketching, it's so that you get the clear picture of how exactly the area looks like. Let's say this is the question that I want us to do next. Determine the area bounded by y is equal to x cubed, the x-axis, and the lines x is equal to 2 and x is equal to 3. Now, Ndumu has asked a question. You see, let's say you have a curve like this. When you sketch, you can have a curve like this, or you can have a curve like this, or you can have a curve like this. So in as much as you have the points of intersection, you can really not be able to get the area because you don't know which part is enclosed by those two curves. From that, yes, you have these 2 points of intersection, but in order for you to determine this area, that area can also, it can look anyhow. You can have this this as your 2 points of intersection, but the area that is wanted is here. So, but just knowing the points of intersection does not mean that now you can be able to get the area. The sketch is very much important. Let's say I have an area like this. This is -2 and this is 2. This is the area. Let's say I have another area like this. This is -2 and this is 2, and the area here is like this. You see, these are 2 different areas. Let's say I have another area like this. The point of intersection is -2 and 2 still, but the area now is like this. The point of, you see, these are points of intersection still. Let's say I have another area like this. This way, point of intersection still -2, 2, but these are totally different areas. So the sketch is very much important. It will show you, you're integrating from here to here, from here to here, you're integrating from here to here. Very important so that you're able to see the area. I hope we are together, Ndumu.